Hey guys, welcome to our next flipped video lesson with inequalities, and today we're going to be solving absolute value inequalities. We've already looked at linear, single variable linear inequalities, we've looked at compound inequalities, and now we're moving on to absolute value inequalities. Well, there is some good news about our absolute value inequalities, is that we are going to be using the same concepts and the same thought process with our absolute value inequalities as we did with our absolute value equations. So let's do a quick review of our absolute value equations, right? If I've got the absolute value of x equal to 6, what is that really saying to me? What is that telling me about my variable? Well, what it's telling me is that x is going to be 6 units away from 0. We also learned that that means we could go to the right 6 units away from 0, or we could go to the left 6 units away from 0. So we know that there are two possible solutions here. X could be at 6, or x could be at -6 and be exactly 6 units away from 0. So we have two solutions. We essentially have two equations here. X is equal to 6 and x is equal to -6. If this concept still isn't clicking for you, please talk to your teacher or come get some help down in the MARC, room 1345, to make sure we clear this up, because we're going to be carrying this through all the way through this lesson today on inequalities. So what happens now when we change our equal sign into an inequality sign? Well, we're going to use the same thought process. We use the definition in this darn thing again, guys, sorry. And we're going to be using the same thought process to to understand and solve here. When we see that the absolute value of x is greater than 6, what that's really saying is x is greater than 6 units away from 0. Another way to say it is x is more than 6 units away from 0. Well, think of a number that's more than 6 units away from 0. Well, we might think 7, or 8, or 9, or 10, and those are correct. Those are all numbers that are more than 6 units away from 0. But just like we could go 6 units away from 0 to +6 with our equations, we could also go to -6. And we have to be thinking about our solutions being more than 6 units away from 0, both going to the right and going to the left. So what this gives us again is, instead of two equations in our solution, we are going to have two inequalities in our solution. Not only will we have x greater than 6, the 7, 8, 9, 10, we're going to have x is less than -6, -7, -8, -9, -10, and so forth. And what this gives us now is not just two solutions, but again, an infinite number of solutions. Let's look at one more absolute value inequality here. So now let's look at the absolute value of x is less than or equal to 6. Well, what this is saying is that x is less than or equal to 6 units away from 0. So what does that mean on a number line? Well, that means that x could be at +6 or closer to 0, and x could be at -6 or closer to 0. So essentially what we're saying is it could be any number including 6 and -6 or in between them. So again, we can see that we kind of have two inequalities going on here. X could be greater than or equal to -6, and x could also be less than or equal to +6. Now you might say to yourself, well, how is this an infinite number of solutions? We've got to remember, in between each integer, in between -6 and -5, there's actually an infinite amount of decimals in between there, in between -5 and -4. So even though we're not going to positive infinity or negative infinity with our solution here, we still have an infinite number of solutions. So now that we've kind of talked about this concept of how we're going to incorporate our definition of absolute value into our thought process for graphing and understanding our solutions, let's actually do some solving here. So I've got the absolute value of x plus 5 is greater than or equal to 11. So what that's telling me is x plus 5 is more than 11 or more units away from 0. So it could be at +11 or to the right, or at -11 and to the left. And what this really leads me to is two inequalities here. We can see that x plus 5 could be less than or equal to -11, or x plus 5 could be greater than or equal to +11. And this is going to be the idea we carry through all of our solving absolute value inequalities. The same way we always had two equations with our absolute value equations, we're always going to have two inequalities to solve with our absolute value inequalities. So when I solve each of these, I subtract 5 from each side, and I'm going to get x is less than or equal to -16, or x is greater than or equal to +6. And then I graph those solutions down below there, just like we did with our compound inequalities and single variable inequalities. Let's look at a couple examples together here. Let's practice a few together. So we've got the absolute value of 6x minus 3 is less than 15. So what this is telling me is that 6x minus 3 is less than 15 units away from 0, meaning it's between negative 15 and positive 15. So one of my inequalities is that it's greater than negative 15 and that it's less than positive 15. That would put it in between the two numbers, right? So I solve both of these by adding 3 and then dividing by 6, and I get x is greater than negative 2 and x is less than 3. So I graph my solution there. Open circles because I don't have the equal sign, and then I'm going to shade the number line in between them because that's where we know our solutions are going to be at. And what this is saying is any number between negative 2 and 3 is going to make this inequality true. Let's look at our second example. Well, one thing we've got to remember from solving equations is that our absolute value expression must be alone. So the first thing I have to do here is subtract 6 from both sides. Once I do that, I have the absolute value of x plus 2 is greater than or equal to 7. So what this is saying is my absolute value, x plus 2, could be 7 or more units away from 0, or it could be negative 7 or less units away from 0. But it's got to be further away, 7 or further units away from 0. So that gives me x plus 2 is less than or equal to negative 7, or x plus 2 is greater than or equal to positive 7. So I subtract 2 from each of them. I get my solutions, and I graph the solutions on the number line. Again, closed circle because we have the equal to there. Okay, and again, that's meaning if I take any number at negative 9 or to the left, that's going to be a solution. Any number from 5 and to the right, and that's going to be a solution. So we've gone over a couple examples together here. So now let's try some on our own. Remember, whenever we're solving our absolute value inequalities, you want to create two inequalities, two single variable inequalities to solve on their own to get our full solution set there. So go ahead, pause the video, and give these four inequalities a try. Take a look at C and D, and remember, make sure you get the absolute value expression alone. Please make sure you show your work. We're not going to give you the work here. We're just going to give you the solution. So we expect to see the work that you did on these problems on your own in your notes. Ready and pause. Welcome back. Let's check our answers here. So take a look at these solutions and take a look at these graphs. See if you got the same thing. If you didn't, please, 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 guys, be writing them down. Bringing the questions to class, and let's talk about them here. This is not the easiest concept to get, but once you do get it, because it's kind of the same similar process over and over again, I think we can be really successful at it. Well, that brings us to the end, and thank you guys for your hard work on this video, and thank you for listening to me for the last, several minutes here. We'll see you a little bit later on the next video or in class.